So good morning to all of you. This is day 3, and today we are going to discuss measures of dispersion, in which we'll be discussing the concept of variance and standard deviation, and what is the importance of standard deviation basically in analysis, and the combination of mean and standard deviation. How we can try to visualize the data with the combination of mean value and the standard deviation value. Fine. So we'll start with today's session. So variance. What is the meaning of variance? Variance, it is a measure of how data points differ from the mean. So the same concept which we are trying to discuss from day 1, that the expected value is 1 and what we have actually is second. And the difference between these two values is called as variance. How my actual value deviates from my expected value. And that deviation is very important in analysis. So a measure of how data points differ from the mean, that is the middle point considering all the weights, central tendency considering all the weights, all the actual values. So that is the meaning of variance. Now I am giving you two data sets with 5 values, small data sets. So data set 1 and data set 2. If you look at both the data sets, can you tell me what is the mean and median of these two data sets? What is the mean and median of these two data sets? Take 1 minute, calculate mean and median for both the data sets.
5, 7 and 7, 7.
For first data set, it is 5 and 7.
Yeah.
Okay.
Yes.
Anyone else?
Sorry, 7, 7 and 7, 7.
Okay. So if you look at data set 1 and data set 2, both has same mean. That means the average of both the data sets is 7. So mean of data set 1 is 7, median is also 7, and mean of data set 2 is also 7, and median is also 7. Now just consider, if I'm not giving you the original data to you, the original data is not with you. If I just give you this information that I have two data sets with same mean as 7 and same median at 7. So how you can visualize the data set if you have only this information available with you? How can you visualize the data set? The data set visualization will be, your thinking will be, both the data sets are similar in behavior. Both the data sets are identical in behavior because both the data sets have same mean and same median. When I say same mean and mean value is 7, that means in both the data sets, half of the values are above 7 and half of the values are below 7. That is my understanding. And when I say median is 7, that means half number of observations are above 7 and half number of observations are below 7. That is my understanding. So when I have two data sets with both mean and median equal to 7, my understanding is both the data sets are identical in nature, but that is not the case. The case is not that. But these two data sets are not identical. The variance shows how they are different. Why these two data sets are not identical? Because of the difference between the values. So if I consider first data set, so first data set is 3, 5, 7, 10 and 10. And if the mean value is 7, then I'll have some deviation from mean. For each data point, I'll have some deviation from mean. So my data is spread across or spread about mean. I'll say the spread of data is more compared to my second data set where I have all the values as 7. So data spread is not there. Every value is present at mean. So if I try to draw a graph, it will be a straight line. But in this case, it will be a kind of curve. So from spread of the data items, from the variance, I can try to visualize the data set. So the important question is mean, any central tendency, for example, is mean sufficient to describe the behavior of any data set? Yesterday we discussed one example that if I have a class of 10 students and if I have to tell the performance of 10 students to somebody who is outside the class, then either I can go for all the 10 marks which have been obtained by all 10 students. That is the first method. Or I can go for a central tendency. That is, I can tell the average score of the class. But even if I tell the average score, that is average score of the class is 7 out of 10. Is that mean, central tendency, average score is sufficient to describe the data completely? Answer is no. And the example we have discussed. Just by knowing the mean value, we cannot completely describe the behavior of any data set. So what we need is, with mean, we have to give the value of variance or standard deviation. When we combine mean and variance or standard deviation, then we can visualize the data set. Then we can tell approximately how my data set will look like. So only mean is not the good descriptor of the behavior of data, but mean in combination with dispersion value, either variance or standard deviation, can describe the data. So this is the introduction part of why dispersion is important. So dispersion is like you are trying to calculate how much spread is there in my data set. How much spread is there in my data set. That is the meaning of dispersion. Okay, so now we'll go ahead. Consider following data. So if I have these data points with me, and then now because we know that only mean is not sufficient, we have to calculate the variance and standard deviation also. I'll try to calculate the deviation of each data point, and then I'll try to calculate the total deviation in my data set, and then I'll try to find what is the analysis of that value. So we'll go ahead. So what is the deviation of each data item from the mean? That is the main question. So consider this data set, the average comes as 6. If you consider average, the mean of the given data set is 6. So suppose this is the average line, the mean line represented by this line. So if I consider first data point 5, what I have to calculate is in terms of 5 minus mu, that is 5 minus 6. For second, again 5 minus 6. For third data point, 6 minus 6, and so on. So I'm trying to calculate the deviation of each data item from the mean. So the deviation of each data item, that is xi, from the mean, that is minus mu, which is 6 in this case. So I'll try to plot these points on the diagram. So first point is 5. The deviation is minus 1. 5 minus 6 is minus 1. Second point, the deviation is minus 1. Third point is 6 itself. That means the data point is present on the line itself. So deviation is 0. Fourth point is 7. So deviation is plus 1. Next point is 9. So deviation is plus 3. Next point is 4. So deviation is minus 2. And next point is 6 again. So it will be on the line itself. So deviation will be 0. So what we are looking at are my total deviations. So this is my deviation value. So this minus 1, plus 1, plus 3, minus 2, and 0 in these two cases. These are my deviations of each data points from the mean. Now what I want to calculate is the total deviation. What is the total deviation in my data set? So if I want to calculate total deviation in my data set, what is the first method I can go with? By logic, I should add all the deviation values, summation of all the deviations. So minus 1 plus 0 plus 1 plus 3 plus minus 2. And if I try to add all these deviations, the value comes as 0. Can anybody tell me why the value is 0? Why the summation of all the deviations is 0? Yes, anyone?
Because we have considered the deviation along with the minus sign.
Okay. Anyone else? Yes. Divya, what is your understanding? Why the summation of all deviations is 0?
Because they're calculated using the mean, so at the end it has to be 0 because it's the mean.
Correct. Okay, fine. So the answer given by Divya is correct, because we are calculating the deviation of each data point from the mean itself, and by definition mean is the central point. By definition, mean is the central point. So if I'm going to consider distance of each data point from the central point, and then if I add all those distances, because of plus and minus, they'll negate each other, and the final answer has to be 0. So that is the meaning of mean, and that is the definition of mean. So it is coming as 0. So the mean value is exact middle value for all the available data set. So the addition of all the deviations from the mean has to be always 0. So we cannot just add all the deviations to calculate the total deviation. And therefore the average deviation will also be equal to 0. What is the meaning of average deviation? If I add all the deviations, then I have to divide this by number of data items in my data set. So right now it is 7. So I'll divide this by 7. So if the addition itself is 0, the average will also come as 0. So only by adding all the deviations, we cannot go ahead and we cannot calculate the total deviation. So there are two methods again available to calculate total deviation. First method is you can take the mod of all the distances. That means you cannot consider the minus and plus sign. You will just consider the distance itself. So -1 is the distance, value is 1 on the other side of the mean. +1 is the distance of the data point on the other side of the mean. Likewise, this -1 and +1 are cancelling each other. So instead of that, if you just consider 1 as a distance value and 1 as a distance value, total deviation comes as 2. So either you can take mod of all the values, so it will take care of the negative sign and positive sign effect, or you can square all the values, because once I square any negative value, it will become square, it will become positive. So there are two methods. Either you can go by taking all the positive values for the distance calculation, or you can go by taking square of the values. So in this course, we are going to consider the square method for the deviation calculation. So variance and SD for ungrouped data. So based on the concept now, we'll try to understand how to calculate variance and standard deviation for ungrouped data. So the definition says for variance, the definition says it is the average of the squared deviation of each data value from the mean. So now we'll look at the definition part first. In this definition, what is important is the deviation of each data value from the mean. That is what we have done in the last problem. So how to calculate deviation of each data value from the mean? Xi minus mu. This is xi is data item, my data items, and mu is my mean. So xi minus mu will give me the deviation of each data item from the mean. And then I need to do the square deviation, because that is what is mentioned in the definition. So when I say square deviation, I have to square this deviation difference, xi minus mu bracket square, and summation of all those squares. So I equal to 1 to n, summation of all square values of deviations, and then I have to calculate the average. So I'll divide it by n. So this is the formula for variance, and the notation is sigma square. Sigma square is notation, and this is the formula for calculating variance. Now what is standard deviation? Standard deviation is positive square root of variance. So standard deviation, it is the positive root of or square root of variance. So SD notation is sigma only. If I take square root, notation is sigma only. Why I'm taking square root? Because I'm making square of all the deviations. Somewhere I have to take square root also to nullify the effect of squaring the deviations. So the standard deviation becomes sigma, which is the square root of this formula, So this is how you can calculate variance and standard deviation for any ungrouped data. Now the formula for group data is different, so we'll come to that. So first we'll try to solve one example using ungrouped data, for ungrouped data. So this is the formula. Suppose this is the data set. So first calculate mean, then go for xi minus mu. So we'll try to solve this problem. So first we calculate mean. What is the mean value? 13?
Yes.
Okay. So considering mean as 13, then we'll calculate xi minus mu. So 5 minus 13, 9 minus 13, 6 minus 13, so on. Now, as per the formula, we have to square these xi minus mu values. So square of all these values, and then summation of all these square deviations comes as 130. And then the formula says it is 130, that is square of all the summation of all the squared values divided by n, which is 5. We have 5 values. So variance sigma square comes as 26, and standard deviation, that is root of 26, comes as 5.1. 5.099 is 5.1. Now, if I tell you the values of mean and maybe standard deviation or variance, Now, can you visualize the data set and the difference between data sets? For example, if I give you 3 data sets with mean value and standard deviation value. So suppose mean and standard deviation, data set 1, 2, and 3. So data set 1 has mean of 50, second also 50, and third also 50. The standard deviation in first case is only 20. Standard deviation in second case is 60, and standard deviation in third case is 110. So now can you try to visualize the data sets, how data sets will be or can be? Any guess?
So lower the standard deviation, the closer the points are towards a mean.
Yes. So my first data set will be something like this. If this is my mean value, which is common for all three, suppose 50, then my first data set, because standard deviation is only 20, that means if this is my middle value, mean value, then the deviation of all data points on an average is very close to all the data points are very close to the mean value. So my data set will look like something like this, where the saturation is there, all the data points, majority of data points are very near to mean. Then the second data set says the standard deviation is 60. So spread is more compared to first data set. My second data set has more spread compared to first data set. So my second data set will be something like this. Compared to first data set, the deviation of all data points from the mean is more from the mean. And then my third data set has a very good spread, that is 110 value. So it is almost kind of a flat curve. So from mean and standard deviation, now you can try to visualize the data set, how my data set looks like. And then you can try to compare two or multiple data sets, the behavior of multiple data sets. So if you want to compare data sets, if you want to compare the behavior, and if you want to understand the behavior of multiple data sets, then you have to have these two values, mean and standard deviation. So, and that's why even if you go for normal distribution, the bell-shaped curve, normal distribution, the normal distribution formula consists of only these two values, mean and standard deviation. So we are not going to cover the probability-based distributions and other things, but in case of normal distribution, the z value is calculated as z is equal to xi minus mu divided by standard deviation. So that is the formula. We generally do it by root n, that is the standard error. But this is the mean formula, xi minus mu divided by standard deviation. So even in case of normal distribution for bell-shaped curve, if you want to calculate the distance, standard distance, you have to consider mean and standard deviation, which is part of the normal distribution formula. Fine. So what is important to understand is only mean is not sufficient to express express the behavior of the data set. We need both mean as well as standard deviation. Okay. Now we'll try to calculate the variance and standard deviation for group data. Now this is the formula for variance and standard deviation for group data. So if you look at the formula, again we are considering MI. So always for group data we consider classmate points, and we have discussed the reason behind considering classmate points. Now suppose these are your class intervals and these are your FI values. So use Excel. Now you know how to use Excel, how to use formula equal to sign and everything. Formula is in front of you, problem is in front of you. functions for group data. But for ungrouped data, so the next problem is ungrouped data. For this ungrouped data, if you want to calculate variance standard deviation, then the first method which we have already discussed, that you can go to data section, data analysis, and then you can go for descriptive statistics. So just select descriptive statistics, click on OK. Input range, so select the data set. Columns, yes, my data is grouped in columns. My first row don't have any labels, so I'll not click on this option. Output, suppose I want to start my output from this location, and then I just want the summary statistics, so I'll click on OK, and what I get is this. So what is my standard deviation? Standard deviation is 6.19 for this ungrouped data, and variance is 38. Second way to calculate this is using the formula. So there is a formula for finding variance as var variance into bracket. You have to select the data set only. Equal to sign, var is the variance function, and into bracket you can select the data set, and then what you get is the variance value, which is the same sample variance 38, same 38.32, but using the formula variance. And then you can calculate the standard deviation, for which equal to std ev is the function standard deviation. Now you can see a lot of other functions with variance and standard deviation for populations and sample with .n.s, but that will not cover right now. So we are going to use the basic functions for variance and standard deviation. So again, for standard deviation, I will select all the values in my data set, and that will give me the standard deviation value. So the same standard deviation and variance we can get using the formula, direct formula. std ev is the formula for standard deviation, and var variance is the formula for variance. So these are the two methods using which you can calculate variance and standard deviation in Excel for ungrouped data. And for group data, there is no other option. You have to go for all these calculations, and you have to calculate variance and standard deviation. Yes. Can anybody tell me how to draw histogram for this data? How to draw histogram for this data? So the bins have been defined, grouping has been done, all the things have been done. We have to just draw the bar graph with no gap. In short, we have to just draw the bar graph with no gap. So you can just select all the frequency values, insert, and then go for the bar graph. You'll get something like this. Look at the x-axis. X-axis is not what we have as upper limits. So click on x-axis, format, axis. Select data, and then in that select data, you have to select the, by default it is 1, 2, 3, 4. Select the upper limits of the class intervals and click on OK. So you'll get all those values on x-axis, and then you can minimize the gap, and that's how you can get your histogram for this data. So again, from the histogram you can see it is not symmetrical. So the histogram is not a normal curve. It is not a normal curve. It is, we are having slope towards right side. So standard deviation shows the variation in data. In short, what we have discussed in last 1 hour about variance and standard deviation, just mean is not sufficient to describe the data. We also want to know the variation in my data points, how my data points are spread around the mean, and based on that spread and then the mean value, then I can try to visualize my data set. So standard deviation shows the variation in data. If the data is close together means if the data points are very close to the mean, close together means close to the mean. If the data is close together, the standard deviation value has to be small. That means the data points are very close to the mean, standard deviation has to be small. And if the data is spread out, the variation is more. If the data is spread out, then the standard deviation will be large. The standard deviation value will be large. And that's why when we discuss the the examples in previous slide, when we say that standard deviation is 20, that results in a distribution with all the data points which are very close to the mean. When I say 110, that results in a distribution where the data points are very at a very far distance from the mean. So mean and standard deviation are helpful in understanding the behavior of data, distribution of data clearly. Now the standard curve, the bell-shaped curve, The bell curve which represents a normal distribution of data shows what standard deviation represents. So by default, when we do any kind of analysis, be it financial or any kind of other domain analysis, we try to get the bell-shaped curve because that is considered as a normal curve. And what is the meaning of normal curve? If the data distribution follows these numbers, then that is close to the normal curve. Like the one standard deviation of distance covers 68.2% of data set. So in all your data set, if it has 100 points, almost 68 to 69 data points should be in one standard deviation. Then the remaining points are distributed into 2 standard and 3 standard deviation, and accordingly you can get multiple numbers like 68, 95 and 99. So if your data set is following 68% in one standard deviation, 95% in 2 standard deviation, 99% in 3 standard deviation, that means your data is following the normal curve. Your data is normal in nature. Your data is normal in nature. And if your data is normal in nature, if your data is following normal curve, then you can do different types of analysis like normal distribution based analysis. So we are going to see few of the examples based on normal distributions in today's session itself. Even in case of bell-shaped curve, you can see, even in case of bell-shaped curve, you can see 0.1% is left before 3 sigma on the left hand side, and 0.1% of data is left after 3 sigma on the right hand side. That means even in case of bell-shaped curve, we are considering that there will be 0.2% of outliers, which will not fit into the common behavior of my data set, which will be beyond 3 sigma, which will be beyond third standard deviation. Now, if you want to consider the concept of standard deviation, now suppose if I consider Pune city, then PMC building, the Pune Municipal Corporation building, I'll consider that building at the central location. And then if I want to consider on the rates for the auto rickshaws, then what I'll do is I'll define some standard distance that from PMC building till 5 kilometers, the standard rate will be suppose 10 rupees per kilometer. After 5 kilometers till 10 kilometers, the standard rate has to be 15 rupees per kilometer, something like that. So what I'm doing is whatever available area of Pune city is, I'm dividing that available area into standard deviations. That what is one standard deviation which is close to the Pune Municipal Corporation building, what is 2 standard deviation from that building, what is 3 standard deviation from that building. And outside 3 standard deviation, which is very far away from my center of the city, I'll consider that part as outlier for my data set. So even in case of bell-shaped curve and normal distribution, I am still considering that there will be 0.2% of data, 0.2% of data, that means 2 out of 100 data points will be outliers. I'm considering 2 out of 100 data points to be outliers. And if you consider this 6 sigma again, why I'm calling this 6 sigma? Because we are having 3 standard deviations on the left hand side of the mu, that is mean, and we are having 3 standard deviations on the right hand side of the mu, that is mean. So total, if you calculate total number of standard distances, that is 6, and this is the concept of 6 sigma. So if you have heard about 6 sigma, which is used for quality control and quality management, then the same 6 sigma talks about standard deviation only. So if you are going for the course of 6 sigma, they'll teach you statistics first, they'll teach you standard deviation first, and then there are standard deviation based calculations, that how many items you can have faulty pieces or you can reject per million products. So that 6 sigma concept is also based on standard deviation. So there are multiple applications of normal data, normal curve, or standard curve, or bell-shaped curve. So as the rule says, as we have discussed, one standard deviation away from the mean in either direction on the horizontal x-axis accounts for 68% of data in one standard deviation. That is 95% data in 2 standard deviation, and it is 99% of data in 3 standard deviation. And this is also referred as empirical rule. This rule of 68, 95, 99, 68, 95, 99, this rule is also referred as empirical rule. Okay. So this is all about standard deviation, and I can say this is a standard deviation in terms of bell-shaped curve or normal curve with 68, 95, 99 rule, which is also referred as empirical rule. This is what we have already discussed about normal distribution. So I'll just give you 1 minute per slide. Just read the content. Everything we have discussed. What is the meaning of normal distribution, bell-shaped curve, the 68, 95, 99 rule. It considers mean and standard deviation and everything. So it is a basically probability based distribution. So normal distribution has been used in a wide variety of practical applications, like random variables like height and weight and test scores, scientific measurements. The form or shape of a normal distribution is a bell-shaped curve. That is what we have discussed. And then why mu and standard deviation both are important? If mu is different, if the mean itself is different, that means the distributions can have identical behavior, but they are not the same distributions because the mean value is different. So the entire family of normal distribution is differentiated by two parameters, which is mu and standard deviation. Both are very important. The mean of the distributions can be numerical values, negative, 0 or positive. So the examples are given. The normal distribution is symmetric. It has to be symmetric around the mean. So we have exact mirror image of left hand side on the right hand side. And because it is symmetric, the normal distribution is not skewed. Its skewness measure is 0. It is not left skewed or right skewed. The standard deviation determines how flat or wide or the normal curve is. So mu is this is my midpoint. And based on standard deviation, if standard deviation is less, the saturation of data points around the mean is more. And the standard deviation is more, the spread will be more. The same thing we have discussed. So what actually we say is, if mu, that is mean, is the midpoint, and if it is symmetrical, that means we have 50% of the observations on the left hand side of the mean, and the 50% of the observations are on the right hand side of the mean in the standard deviation, as per the standard deviation. So this is important. Just remember this: we have 50% on the left and 50% on the right in case of standard deviation. So this is our 68, 95, 99 rule, that in one standard deviation we cover 68.2, 68.3% of data. In two standard deviation we cover 95.4% of data, and in three standard deviation we almost cover 99.7% of data. That is 68, 95, 99 rule, which is also called as empirical rule. So in addition to the measures of location and variability, shape and other important aspects, the important aspect is relative location of values within the data set. So what is my relative location of my data point from my mean? So z-score gives the relative location of each data item from its mean. So why we use z-score? Z-score gives the relative location of each data item from the mean. So we know that data items are spread around the mean, and that spread is shown by the standard deviation. But if I consider any specific data point, how that specific data point is at some distance from the mean, if I am to calculate that distance, that is your relative location, and that is given by z-score. So z-score will tell you the difference of each data point from the mean. What is the relative location of each data point from the mean? Now if you look at this diagram, why I am saying relative location? Because I am considering mu as 0. In our actual data set, if I consider actual data set and if I draw the bell-shaped curve of my data set, even if it is similar, my mu will be something different. Suppose it is 50. Considering mu as 50, if I am to calculate what is the distance of this data point from the mean, then this becomes a relative location in terms of mu equal to 0. So what I'm trying to do is I'm trying to map all my data distributions on this standard distribution. I'm trying to map all my data distributions with different mean values onto this standard distribution so that my mean will be 0 and I can calculate the relative location of all the data points. Because considering 0, if the distance of this data point from the mean, if it is suppose 1 unit, for example, this 1 unit will have some different value considering mean is equal to 50. If mean is equal to 50, 1 unit data point will be something different. So what we are trying to do is, I can have a data set with mean equal to 50. I can have a second data set with mean equal to 100. I can have a third data set with mean equal to -10. It can be anything. But I'll try to map all three data sets with different mean values on a standard curve with mean equal to 0. So that it will be easy for me to calculate the standard distance in case of relative location. So you'll see in this diagram for z-score, we consider mean at 0 and my standard deviation is equal to 1. Okay. Fine. So we'll try to solve some examples also. So okay, look at this example. Suppose we have a sample of n observations denoted by x1 to xn. Assume that the sample mean is x bar, simple, and the standard deviation is s. Then the zi, how to calculate that distance? Zi is distance, nothing else. What we have discussed, that how to calculate z score is xi minus mu upon standard deviation. That is a formula. So even in case of normal distribution, what we consider is mean and standard deviation. Mean and standard deviation. These two notations are important. So xi minus x bar divided by standard deviation, SD. So you can consider in a distribution, if this is my x bar or mu, if this is my xi, some data point xi, what my numerator I'm trying to do is xi minus mu. I'm trying to calculate this difference, xi minus mu. I'm trying to calculate this difference. Okay. So this is the actual difference or actual distance of xi from the mean. Now if distance is this, in terms of standard deviation, this distance is what fraction of standard deviation? If I want to calculate this distance is what fraction of standard deviation, so I'm dividing this distance by standard deviation, SD. I'm dividing this distance by standard deviation, SD. So if I divide it by standard deviation, I'll come to know what fraction of standard deviation at my xi is from my mean. Okay, so the z score zi can be interpreted as a number of standard deviations xi is from the mean x bar. And that is how the normal distribution concept says that we are trying to calculate the distances of all the data points from the mean, considering mean at 0 and standard deviation at 1. Okay. So look at this example. Suppose the standard distance comes as for any point 1.2, would indicate that x1 is at 1.2 standard deviation greater than the sample mean. So if I am saying z1 is equal to 1.2, that means my first point x1 is at 1.2 standard deviation from the mean. So if I try to plot this z1 or x1 in my curve, how can I plot? If z1 is 1.2, z1 is 1.2 means what? From mean, my x1, this z1 is for x1, correct? We calculate zi for xi. For each xi, the distance will be zi. Okay, so for x1, the z1 says 1.2. That means the distance from the mean is 1.2. So if it is positive, it has to be on this side, first thing. And if it is negative, then it has to be on this side. Now the distance is 1.2. So when I say 1.2, that means it is somewhere here. So my xi can be somewhere here. So it is 1.2 is one complete standard deviation and fraction of second standard deviation. So if this is my one standard deviation, then it will be after one standard deviation somewhere here. Xi will be somewhere here. So I can try to plot in reverse way also. I can try to plot my data points if I know the distance. So simple. If I know the data point, I can calculate the distance. And if I know the distance, I can plot the data point. So both ways I can use z score. The normal distribution problems. So this is the empirical rule. And this is the z table which I have already shared with you. So all of you have this z table copy with you. Just a minute. Okay, so all of you have the z table copy with you. And this is the formula. So everything is with you now. Formula is with you. Z table is with you. I'll give the problem and then I'll tell you how to solve the problem. The formula says it is xi minus x bar upon standard deviation is zi. So if I'm calculating everything for my first data point, I'll denote it as x1 and that will give me z1. For x2, it will be z2 and so on. Okay. So I can calculate zi for all my data points, the z value for all my data points using this formula, and using this table, I can calculate the distance. Suppose IQ scores have a bell-shaped distribution with a mean of 100 and standard deviation is 50. Simple values are given. Mean is 100 and standard deviation is 50. I want to calculate what percentage of people should have an IQ score between 85 and 150. If the mean is 100 and standard deviation is 50, I want to calculate how many, what percentage of people should have an IQ score between 85 and 150. Okay. So how to solve these kind of problems? So step number one, always remember, step number one is you have to draw the distribution of data. You have to draw the distribution of data. Then plot the mu, which is given 100. Okay. Now plot the points, data points for which you want to calculate the percentage, 85 and 115. So this is your x1, 85, and this is your x2, 115. Then use the formula. Formula says z is equal to x minus mu upon standard deviation. So you have to calculate z for x1 differently and x2 differently. So if I calculate z for both of these points, my z comes as minus 1.0 and plus 1.0. So these are my z values. So once I calculate the z values, then we have to refer the z table and then calculate the distance. So somebody has done all these kind of analysis. If z is equal to 1, what is the distance from the mean? If z is equal to 1.5, what is the distance from the mean? If z is equal to 2.5, what is the distance from the mean? So we don't have to go and calculate the distances. We just have to go to the z table and look at these z table value for minus 1.0, and you can come to know the distance of that data point from the mean. So now the value of z is minus 1 and plus 1. So we'll not consider the sign minus and plus, because that table only tells you the distance. What distance means z equal to 1. So the minus sign only indicates distance is on this side or this side of the mean, right hand side or left hand side. But the distance is distance itself. So we'll consider only 1.0. Now how to read z table? So there is a rule to read z table. Suppose my z value comes as 1.23. Just consider if my z value comes as 1. So the z value, if it is coming as 1.23, for example, then how you can read the z table using this z value? You have to split this z value into two parts. You have to split this z value into two parts as 1.2 and the remaining part as 0.03. 1.2 and 0.03. If you add 1.2 and 0.03, it will come as 1.23. So whatever is the first digit after the decimal point, the first digit after decimal point, till that point you have to split the first part of your z value and the remaining part as second part of your z value, 0.03. So suppose if my value is 0.97, then I have to split this 0.97 as 0.9 and 0.07. 0.9 and 0.07. Suppose if my value is 2.58, then I have to split this into 2.5 and 0.08. So this is how you can split whatever z value you have got, and then using these two values you can read the z table. Using these two values you can read the z table. Now we have got the value of z as 1.00. 1.00. So we'll split this into two parts as 1.0 and 0.00. 1.0 and 0.00. That is how we are going to split this value, and then we are going to read the z table. Now you open your z tables and try to read the z table. Now what is the meaning of this z is equal to 1? That my x1 is at 1 standard deviation from the mean and my x2 is at 1 standard deviation from the mean on the right hand side. That is the meaning of this 1. Okay. So now we'll try to read the z table. So go to standard normal z table and look for 1.0 value. So we have done this split, and the two values are 1.0 and 0.00. So look for row of 1.0 and column of 0.00. Look for row of 1.0 and column of 0.00. So row of 1.0 is this and column of 0.00 is this. So what we get is this value, 0.3413. 0.3413. We are going to solve at least 5 to 6 more problems with complex z values also. So don't worry. We are going to see how to read z table very clearly. So my current value for 1.0, z is equal to 1.0, is 0.3413. Now this is your distance. For 1.0 z value, the distance is 0.3413 from the mean. From the mean. So what is the meaning of this? The distance of x1 from the mean is 0.3413. The distance of x2 from the mean is also 0.3413. So the total number of observations, the total percentage of population between x1 and x2 is the addition of these two distances. That is the total distance covered by x1 and x2. So if I add both of these values, it comes to 0.6826, which is 68%. Almost 68% of the population is having IQ between 85 and 115, and that is a cross check that one standard deviation, as empirical rule says, one standard deviation covers 68% of population. Two standard deviation covers 95% of population, and three standard deviation covers 99% of population. So what number percentage of population is covered by one standard deviation is 68%, and we are getting the same value using the Z table. 68%. So 68.26% of the population is having IQ between 85 and 115. So this is how you can solve the problems using Z values. Okay. So we'll solve another problem. We are going to solve 5 to 6 more problems. So can you go to the next? Can we go to the next problem? Yes. Have you understood this problem?
Yes.
So Z value comes as 2.0. On one side it is -2, on second side it is +2. So the total distance has to be 2 plus 2, that is 4. How to read Z table? We'll split this into 2.0 and 0.00. So if you look at the Z table, this is the value 4772, 0.4772. So I can say that x1 is at the distance for 0.4772 from the mean, and even x2 is at the distance 0.4772 from the mean. So the total distance covered by x1 and x2, between x1 and x2, the number of data items, percentage of population between x1 and x2 is 0.9544, almost 95%. 95.44% of the population is having IQ between 70 and 130. And that is the empirical rule of two standard deviation. Two standard deviation covers 95% of the population. 70 and 115. So plot the points, 70 on one side, 115 on the second side. Because 70 is less than mu, so x1 has to be on this side, and 115 is greater than mu, x2 has to be on this side. Now if I calculate Z, Z comes as 2.0 on one side and 1.0 on other side. So it is not necessary that you will get Z values same on both the sides. It depends on where is your x1 and where is your x2. So you have to read Z table twice, once for 2.0, once for 1.0. So x1 is at 2 standard deviation distance from the mean, and x2 is at 1 standard deviation from the mean. So we'll look at the Z table for 1 standard deviation and 2 standard deviation. We are having these values 0.3413 and 0.4772 for 1.0 and 2.0. So that means my x1 is at distance 0.4772 from the mean, and x2 is at a distance 0.3413 from the mean. So if I have to calculate total distance, I'll add both the values, comes as 81.85. So 81.85% of the population is having IQ between 70 and 150. Okay, so just plot the x1 and x2. So x1 is 89 and x2 is 114. So if you calculate Z value, Z comes as 0.74 for x1 and 0.933 for x2.
So 0.73 for x1.
You are getting 0.73.
Yes, sir.
Okay, that is also okay. This much of difference in calculation can be there, because it depends on if you are using a scientific calculator, if you are using a normal calculator, if you are using Excel, if you are doing manually. So some fraction difference will be there. So this is okay. Yeah. So you can just go on mute. Okay, fine. So this is my Z value for x1 and this is my Z value for x2. So how to split this into two parts to read the Z table? For this, I'll split this Z into two parts as 0.7 and then 0.03 or 0.04, depends. And this I'll split as 0.9 and 0.03. So for these values, I have to read the Z table. So I'll go to the Z table. The meaning of these values is my x1 is at 0.74 standard deviation from the mu, and x2 is at the 0.933 standard deviation from the mu, from the mean. So we'll go to the table now. First is 0.74. For me, it is 0.74. You can consider 0.73 if your answer is 0.73. So your answer will be 2673. Slightly less, not much. Slightly less. Okay, it will. The difference is 0.01 something. That is okay. And the second value is 0.3238. So I have to add these two values. Correct. I have to add these two values to calculate total distance. So the total distance comes as 5942. So 59.42% of the population is having IQ between 89 and 114. Clear? So you want to calculate. This is your x1. This is your x2. Right now we are not considering x1. We have only x2, which is 130, and we want to calculate this area, distance of this area. So what is the percentage of population in this area? Okay. So now first we'll calculate Z for x2. We'll go by normal method. The Z comes as 2.0. So my x2 is at 2 standard deviation from the mean. So I'll go to the Z table. I'll look for 2.0. It comes as 0.4772. The distance is 0.4772. Now, as per the definition of bell-shaped curve, the definition of bell-shaped curve says my mu, the mean value, distributes my normal curve into two equal parts of 50%. So 50% of my bell-shaped curve is before mu and 50% of my bell-shaped curve is after mu. So this part of my bell-shaped curve is 50% of the bell-shaped curve. So if this is my 50%, and out of this 50%, if this distance is 0.4772, if this is the 50%, and if this is 0.477, 50% is 0.5. So the total distance is 0.5, out of which it is 0.4772. So what I have to do is, I have to subtract this 0.4772 from 0.5 to calculate the remaining distance. So the remaining distance comes as 0.0228. 0.0228, that means only 2.28% of population is having IQ more than 130. Is having IQ more than 130. Have you understood? Is it clear now? The area to the left of Z is 0.9750. So where my Z can be?
The positive side.
Why?
Around 2 sigma side.
So 9750 on the left hand side. So that means I have to consider the complete 50% on the left hand side of the mu, and remaining 4750, which is from the mu on the right hand side of the Z. And that 4750, if I look at the Z table, how can I go back to the Z table with 4750?
1.9.
Yeah, I'll look for close value for 4750. 4750 is this. So it is 1.96. So my Z value is 1.96. So answer for first question is 1.96. Any doubt? Do you want me to explain again? Anyone? Okay. So it seems all of you have understood. So considering the first problem answer is 1.96, solve the remaining problems and tell me the answers in next 2 minutes. Yes. So first and second is same actually. First and second is same. The only thing is second, don't talk about the direction. The distance from 0 is 0.4750. It can be on both the sides. So I always tell you that you draw the curve first to solve the problem. So 0.4750 on both the sides. So it can be on both the sides. So and 4750 is 1.96. So the answer for second is 1.96 on positive side and 1.96 on the left hand side. That is the answer for B. Answer for A is only this. Only this is answer for A. What is C? The area to the left of Z is 7291. So similar to A, it is similar to A. You have to subtract 0.5 from 0.7291. And what is the remaining number? What is the remaining number? 0.2291. Yes, 0.2291. So you have to find the Z table for 0.2291. So 0.2291 is here and the value is 0.61. So my 0.61, that means somewhere here.
61.
So this is my C. Okay. Then D, area to the right of the Z is 0.1314. Area to the right of Z is 0.1314. So my Z is somewhere here. On which side? My Z is
Right side.
left hand side of mean. Is it left hand side of the mean or is it somewhere on this side?
This side, right side of the mean.
Right side? Okay. So area to the right of Z is 0.1314. So my Z is somewhere here. And right of Z is on this side, that area is 0.1314. So my total distance on the right hand side is 0.5, out of which this distance is given as 0.1314. That means I can know the distance from the mean till this point by subtracting 0.5, 0.1314. So what is the answer?
0.3636.
0.3636, suppose. Okay. 0.3636. So where is 0.3636 in my table? If I look at my table,
1.1.
okay, 1.10. Is there any value in 1.07, 1.08, which is close to 3636? Just see, I'm not showing that part of the table.
1.09 is also close.
What is the value of 1.09?
3621. 0.3621.
Yeah, so that is more close. 1.97 is more correct answer. Okay, so for this D, 1.97 is the correct answer. Okay. E, the area to the left of Z is 0.6700. So on which side my Z is? On
Right
which side?
side.
Right side of mu, very correct. And then you can solve also,
Right
you can
side.
find the answer also. And likewise, you can solve the F also, correct? So now you have understood how to read Z table, how to solve the problems, even if the problem is given with mu and standard deviation, or the problem is given in terms of Z values. Okay. So that's it from my side for today's session. In today's session, we have covered standard deviation, variance conceptually, application of standard deviation in terms of bell-shaped curve, and then we have also solved some problems based on bell-shaped curve using normal distribution. Okay. So that's it from my side for today's session. Tomorrow we'll start with other things.